Hi scientists! In the first video about gravity, we tried dropping objects of different weights and sizes to see if they would land at the same time. And they did. But some of you tried other things like feathers. And you said the feather did not fall as quickly as the ball. So I'm going to try that right now.
Why do the feathers fall slower than the ball?
Did you think about it? Did your answer have anything to do with the air? In the last video, I mentioned that gravity is all around us and we can't see it, but we can feel the effects of it. In fact, there's lots of stuff all around us that we can't see, but we can feel the effects of it. There's radio waves and light rays and, of course, the air. We know we can feel the air because when you push your hand, you can feel something going across you, or if a breeze blows, you can feel the breeze on your skin. So when I dropped that feather, it was falling, and the air that's around it, even though the air wasn't moving, was providing some resistance. Resistance. What does that mean, resistance? Resistance is when you have something pushing against something else. That causes resistance, and there's all kinds of resistance too. So as the feather was falling, the air was providing some resistance. But there's some interesting experiments you can do here because there's, of course, lots of things, not just feathers, that will follow slowly. This next experiment, I'd like you to get 2 pieces of paper. If they're already used pieces of paper, that would be great because then they would be getting a second use and being recycled. But I have 2 pieces of paper and we're going to try an experiment. And since they're exactly the same size, and let's assume that they're identical twins and weigh exactly the same amount. What I'm going to do with one sheet of paper is leave it flat. What I'm going to do with the second sheet of paper is crumple it up into a ball. I still have 2 pieces of paper, but one sheet is still flat and one sheet is crumpled up into a ball. Do you think they still weigh the same? I think they do. Nothing happened, except I crumpled up one. So they still weigh the same, even though they have different shapes. Let's test it out and see which one falls faster. 2 sheets of paper, exactly the same weight, but this one fell faster than that one. That proves that there's some kind of force acting on this piece of paper. I think because it's much bigger and catches more air. Kind of like a sail on a ship. Which one do you think would make a better sail? This big flat one or this crumpled up piece of paper? So why don't we try right now crumpling up this sheet of paper. Hey, it's gone, magic. No, it's right there. So let's try these 2 sheets of paper now to see which falls faster. They hit at the exact same time. They weighed the exact amount, not that it would make a difference. But let's try that out. Just to be scientific, I'm going to try the baseball in one of those crumpled up sheets of paper to see what happens. Yes, they did fall at the same speed, the baseball and a piece of paper. Even though they're different weights, they still fell at the same rate. A really great example of a compacted or crushed thing compared to its unfolded version causing a big difference when they're falling is a parachute. Think about it. If you put the parachute in your backpack and jump out of a plane, you fall really fast towards the earth. But as soon as the parachute comes out, it slows you down so that you land gently on the ground. Another really, really interesting thing to think about is what happens to things in outer space. Because in outer space, there's no air. So if there's no air, there's nothing to slow them down. So I could throw a feather like I could throw a baseball. When the astronauts landed on the moon, one of the experiments they wanted to conduct was proving that a feather and a hammer would fall at the same rate. The captain of the Falcon mission dropped a feather and a hammer at the same time on the moon and watched them fall to the ground at the same time. Why? Because there's no air on the moon to provide resistance. Can you duplicate that experiment on Earth? Yes, you can. Scientists have created a space called a vacuum chamber where they suck all the air out, and then there's no air in the room, so they can conduct experiments. And as you'll see in this video coming up, but what's a vacuum? Is it that noisy thing that you clean up a room with? Well, it's very similar to that, because what a vacuum does is it sucks the air, and while it's sucking the air, it's pulling the dirt out of the carpet. And so they use giant vacuum motors to suck the air out of a room. In this video, you'll see a giant vacuum chamber. And even though you can't tell it doesn't have any air in it, it doesn't. And the way you can tell it doesn't have any air in it is that the two items fall exactly at the same speed. So there's no air resistance.
The first experiment will be in the big chamber while the air is still in it. So, as you might expect, the ball will fall much faster than the feathers because of the air resistance. In the second experiment, all the air has been removed from the giant vacuum chamber. So when they drop the ball and the feathers, there's no air resistance. As you can see, the ball and the feathers fall at exactly the same rate.
I hope you enjoy conducting some of these experiments at home. Please let me know what you find. I'm always interested to find out what your scientific research shows. Have fun.